Hi, alright, let's talk about Chapter 7, using GIS to make a map. So at this point you have done 2 different lessons in ArcMap, and so you should be feeling a little bit more comfortable with the different little bells and whistles that you can do. And if you haven't read ahead on the Moodle about what I've said about making maps, I'll just reiterate here that making maps is officially known as cartography, which is a whole subject of study in and of itself, like so many things. But it's very important to know the fundamental aspects of what makes a good map, what makes a good visual presentation, because ultimately everything we're doing with GIS is about communicating an issue or a problem you've solved or some new analysis, and your point's not going to get across unless you can communicate it effectively and clearly. So we're going to talk about some basic map making skills and ideas, and also a little bit of some statistical representation that goes into creating meaningful maps. So to start, here's a list of my philosophy of the map. This is my opinion. This is just me. This is from my experience. But a lot of it's true, I think. For instance, the idea that maps are static. When you make a map and print a map out, that's just a snapshot, but the GIS data is often changing. So just remember that when you are seeing a map, know that it is actually, again, a snapshot representation. Although now with the advent of ArcGIS Online, we can actually trust that maps are a lot more dynamic, that they're actually reflecting a lot more changes in the world. So like any written material, maps have messages and an audience, and this should be clear what that audience is and what your intention is when you're designing your final map layout. And good communication happens through good visual design, and when in doubt, keep things as simple as possible. And also, because maps are tools of communication and they have a human author, they're also subject to bias. So if you're using data, cite your data. If you're using another person's map, cite that map. So it's important just to have those elements visible on your map, just like you would in a research paper. And it's important to remember that map making is a science, but it's also an art. So there's a lot of style, there's a lot of design, there's a lot of kind of non-verbal or non-reading things that go into it that as a user you probably wouldn't think of, but as you start to do more of it, you'll realize are very important. So let's start with the basic map elements. You can see here on this illustration, we've got a neat line, we have borders, we have a title, legend, scale, credits, north arrow, place names, any insets, and the main figure, and then the ground, of course, which is the background. And like I say on the side of the screen here, not all of these are always necessary for all maps. Really, you just have to choose the information that's essential to getting your point across. But these are the core elements that you'll be dealing with. So in terms of my own preferences, I don't like neat lines. We'll go back and see neat lines are these things, these borders and side borders. I think they just look cluttered. But again, that can be your own preference. I don't always use a north arrow. It's not always necessary. Again, if we're looking at just putting on what's essential, there are times when I think it's fairly implicit what north is, but we still have to put it on. We just have to determine who our audience is. I personally like to use complementary fonts, and legends don't need to say legend because we know what a legend is. You have to have a short descriptive title of what you're actually labeling. And titles should be descriptive as possible, i.e. a map that shows population density in the USA normalized by income in the year 2003 using Choropleth should actually say that, or to some extent. And coloration is a very important part of your communication strategy. There are actually certain colors that are used by certain industries to label, say, like soil or weather or different land cover types. So do a little research to see if there's pre-existing colorations that might be useful for what you're doing. So let's talk a bit about scale. Scale is actually kind of confusing in some ways, at least it has always been a challenge for me when we talk about small scale versus large scale. So the important thing to remember is that while we can see what the scale says on a map, we have our examples of verbal scale, representative fraction, and representative fraction, and you can see how they play against each other. But when we talk about large and small scale, in a lot of ways, we're actually talking about how does one map compare to another map. So if we look at these examples here on the left, we see this map of all of the United States, the continental United States. Now compared to the third map down, where we just see this region, this southern East Coast region, this would be considered the larger scale, and this is the smaller scale. Same thing here. We have, this would be larger than this one here. But then this would be, so you can see, you know, it's kind of what we're getting at. In my mind, it's always about what you see is labeled the opposite of what you would call it. So when I look at this, I call it small scale, because even though the United States looks large, because this is where it always gets me, the United States looks big, but all the features are actually quite small, so all the important stuff we're looking at is actually very small. But when we compare it down here, this is considered large scale. We're actually looking at a small area, but it's the features that we're looking at are actually much larger relative to the map size. So over here I go into a little bit more detail about how I sort of elicit how to make that comparison in your own head. So small scale means a larger amount of area with lesser detail, whereas a large scale map is a smaller amount of area with a greater amount of detail. So again, you'll get used to this as you go along. Here I've tried to draw out some more comparisons and to show that it's a lot about how you're talking, what you're talking about, and how you're comparing things. This example drives it home a little more for me here, because down here this is large scale because in this example, quite literally, the buildings are large. You can see the footprints, the polygons that represent the buildings. Those are large. So that means it's a large scale map. The features that we're looking at are large. When we compare it to the one up here, it's small scale because we can't see any of the buildings. We can't even see even the outlines of the towns. All we're seeing is dots where we think the towns and cities are, or where they are. Not where they think they are, but where they are. So it's a much smaller scale. So let's talk briefly about statistical classification methods. If you guys have taken any statistics, these might sound sort of familiar to you. This is a whole other area in map making, and as you go through GIS, if you continue on with it, you'll start to get to know these a little bit more as you work with these different breaks and measurements in statistical data. But let's just say that how you choose to break your data, if we compare these here, can change the meaning of the message of what the map it is you've made. For instance, here we're using natural breaks, and we see that there's more, there's a lot of green, but there's a lot of light blue here too. But then we take the same data, so this is all using the same data, I should say, and we use quantiles, which is a different way of representing the data in their even amounts, and the data looks very different. So this is telling a very different story between these two maps. And then we look down here and we see the same thing, extremely different down here when we use equal intervals. So it really can skew the message of your data, and if you haven't already been exposed to this, this is something that you should always question when you see statistics used anywhere in the media or in any source, because it can be used to fundamentally wrap around and make it give the viewer or the consumer of the information, it can manipulate what it is they're thinking. So just bear that in mind. So let's talk quickly about the two different main kinds of maps. We have reference maps and we have thematic maps. So reference maps are what we're used to seeing when we are traveling into a new city and we want to know where. We're looking at a fold-out map. We've just gotten to Paris, and it shows us where all the streets are. It shows us where the main tourist sites are, and it shows us where the river is, where the Seine is. That's a reference map. It's showing us features. This is versus the thematic map, which is, as I say here, displays a particular theme or attributes of features. So if we look back, say for instance, at these maps, these are thematic maps because they're showing us attributes of the seasonal homes data. We're not using it for reference. We're not using it to find our way or to locate a city or Notre Dame or something. And we see a lot of these used all over the place. Both of these kinds of maps are used quite often. So let's take a quicker look at a reference map. This is just one I pulled up from online. You can see that it has borders, political boundaries, it has roads and road types, it has place names, it has the neighboring states, it has settlement types. This reference map could also have mountains, rivers, valleys, railroad tracks, different elevation, whatever. But there's no analytical element to the map. There's nothing that's showing data normalized against other data. There's nothing indicating that a phenomenon is occurring. So when we go to thematic map types, there are many different kinds. These are the sort of core ones that you'll see a lot when you're first starting off in GIS. So we have choropleth, which is very tempting to say chloroplethe, even though it's choropleth. It's tempting to say choropleth because it's dealing with colors. You're dealing with colored maps. So that's what choropleth means. Proportional or graduated symbol, dot density, isarithmic or isopleth, cartogram, and asymmetric. And as I say below, each map is derived from different forms of statistical analysis of the attribute data, and what you choose depends on what kind of problems you're addressing. I'm not going to go into this in depth. You guys can flip through this and read a little bit more about how these different kinds of statistical mapping methods are created and what they're used for. But here's some good examples if you just want to like start referencing and getting a sense of what it means. So here's an example of choropleth. You can see how color is used to show distribution. Graduated symbol is pretty obvious. It just shows, uses symbols. It'll use pies or circle charts to indicate either size or proportion within a region of a certain phenomenon or feature. Dot density. Dot density is actually very useful when you're looking at individual instances of one thing occurring. In this case, you're looking at actual small dots of MSR occurrences. I'm sorry, MSR. I was thinking of something else. It is MSR, but I was thinking of a superbug. Anyway, this does actually show each dot represents one occurrence, and so you can actually get a good sense of what the distribution is and the density is of those occurrences. Isopleth, these are like basically weather maps. So when you watch the weather on the television and it shows you, you're looking at the Weather Channel or CNN and it shows the whole country in these kind of pretty, groovy undulating lines and zones. That's an isopleth map, and that's another form of data analysis using generalization. Cartograms actually will distort the shape of a place based upon in this case, its population size relative to others. So these are very interesting to see. You can see how big India and China are compared to other countries in the world because they have the highest populations. And asymmetric is actually also very interesting. It's showing two different things happening. It's showing, for instance, we have population density in counties, I think, in this layer here. But what we don't think about is when we see population density represented by county, is we're not actually seeing the density within that county itself. So this would give you the image that population is distributed evenly in the county, when in fact that can't be the case. Most of the time, density is concentrated in one spot where there's a city. So you can see down here, there's more density here, and yet the whole area is red. So what asymmetric tries to achieve is to show you that distribution within an area. So let's talk a little bit about the actual interface with GIS when we're looking at map making. This is called, so far you guys have been working in this area. This is called the data view. This is where you do lots of your analysis. You can change the colors, you can change the numbers, you can do some of your statistical stuff, which is happening here. Down here we see the classification window where you can change the different kinds of breaks and the different kind of statistical representation you can do. But this is where you're actually doing the sort of map design, the more kind of catchy fun side of cartography, which is the layout view. And I think I've pointed this out before, but you toggle between your layout view and your map view through down here, these two little buttons. This one on the right is for layout, and the one on the left gives you your map view. So you can switch between the two of those with relative ease. So in terms of GIST, map making is a fundamental outcome. The ultimate aim of geospatial technology is to generate data and refine methods for analysis and representation that communicate a message to or solve a problem for an audience. So if you're interested in seeing a little bit more about Do Maps Lie, there's a nice little video here. I have the link in it in the presentation. Check that out. I've also included in the course Moodle page a tutorial on how to create a graduated symbol map, I think, or is it a choropleth? I'd say just watching it, it just lets you see a little bit about how somebody goes in and clicks around and achieves that goal, and it's always very useful to see somebody else doing the clicking around before you do. So with that, I will call it a day. Thanks very much.